Or talks of 15 or less minutes. Okay, Mr. Troublemaker McRae is going to waffle on, is he? Right. So, you know, the quicker the talks go, like I said, the quicker we all get to the beer. So, first talk is from Bradley Freeman, who works for Janet UK, and he's going to be talking about BGP and OSPF CPU utilization.
Hello, this is a bit of research I actually did as an undergraduate before I started working at Janet, so it's about 6 months old, but hopefully you'll find it interesting. It's been said, and I'd say reasonably commonly thought, I've been taught it, and it's been said a couple of times, that the Dijkstra algorithm is more CPU intensive than distance or path-based vector algorithms. I looked into this, and there's very, very little quantifiable evidence. It all seems to be people saying it's true and saying this is correct. There only seems to be real research done into the memory requirements because of people asking on mailing lists, how much memory do I need to run a BGP routing table? But there's very little research done into the CPU utilization, so I looked into that. So if I'm looking into it, I've got to build a couple of tests. So I decided to run some tests with BGP and OSPF, and I had 7 Cisco routers lying around my bedroom, as you do. So I built them into a network. And the variable used in my experiments, I was changing the number of networks being advertised in a single networking event. So I had 4 loopback interfaces with 1, 10, 100, and 1,000 IP addresses attached. I used secondary IP addresses to have 1,000 IP addresses on a single interface. All the IP addresses were in different subnets, and each subnet related to a separate entry in each routing process. So thereby shutting or no shutting one of the loopback interfaces, that router would then propagate all of the updates throughout the network. Auto summary was turned up, so there was no summarization going on, so every individual network on router G went throughout the network. For BGP, I didn't want the best path selection algorithm to kick out one of the first 2 hits, so I made it change on AS path, so every router within its own AS. And for OSPF, I wanted to have it all, the entire network visible, to make the Dijkstra algorithm, the SPF algorithm as complex as possible, so it was all in OSPF area 0. I measured the CPU utilization in milliseconds by connecting to the router via telnet from a management monitoring server, and I think the command was show process CPU, and I could see the CPU utilization in milliseconds for each process running. I didn't choose to use SNMP because there was no MIBs that were available that had the granularity of the data I did. So I connect to the router, I would get the CPU utilization in milliseconds, I then shut or no shut one of the loopback interfaces, those changes would propagate, and I'd connect back 60 seconds later and collect the new CPU utilization in milliseconds. Obviously, I'm connecting to the router and running commands, so that's going to be using some CPU. So I made sure that I worked out the CPU utilization of me just connecting to it when it wasn't running a routing process, and I took those figures away. Anyway, the results of my experiment. For BGP, this graph shows the average CPU utilization in milliseconds for BGP updates in 1, 10, 100, and 1,000. And what really stands out on this graph is at 1,000 routes, the BGP router process is really, really high. It's over 1,000 milliseconds. That's quite considerable. When we compare that to OSPF, now bear in mind the scale of this graph is going to change because that goes up to 1,200. But with OSPF, it only goes up to 300, and there isn't that much variation between the number of routes. Everything else is kind of the same. So I decided to look a bit further into the OSPF and BGP router process, and in both cases, for BGP, the BGP router process was using about 75% of the CPU utilization, and for OSPF, it was using, again, about 75% of the CPU utilization. According to some books I read, the SPF algorithm is calculated in the OSPF router process, and likewise in BGP, the best path selection algorithm is calculated in the BGP router process. So for the real meat of the presentation, if you calculate the millisecond runtime of BGP routing process, and you increase the number of routes exponentially, directly the CPU utilization in milliseconds of that process increases exponentially. But with OSPF, it's slightly different. It seems to be quite linear. There's a bit of statistical deviation at 1,000 routes. I wasn't too sure why that was. I could go into it a bit further. But to be honest, I just wanted to get the research done and get a job. So if you plot the 2 graphs together, it's quite interesting that at around about 320 routes, it appears from this graph that OSPF is more efficient in terms of CPU utilization than BGP. So So this provides an insight into the implementation of these protocols within Cisco IOS. I stress other vendors may implement it entirely differently. This is all internal within that BGP or OSPF router process. And the reason is because from the evidence I've seen is that OSPF, a single SPF calculation is performed per destination. But with BGP, the best path selection algorithm is performed per route. So thereby, around about 320 routes, as I've said, OSPF is actually more efficient in terms of CPU utilization than BGP. Obviously, it's not a great study, and I label this slide some shortcomings. Some other person who I work with who's a bit more of an academic than me suggested I'd use further research required, but I couldn't be bothered, to be honest. So obviously, a lot more research can be done. Ideally, you want to use a processor-independent method of calculating the CPU utilization, because the CPU utilization in milliseconds is only relevant to that particular CPU, and a vendor-independent approach might be done. But I hope you found that interesting. Cheers. Any questions? Ooh. Yeah, I used iOS versions 12.3 and 12.4. I didn't have access to the Cisco website to get the new ones as much as I'd like to. It was just equipment I had kicking around. It was all physical routers. I didn't use any simulated equipment. It was all actual real hardware. Cool.
Thank you, Bradley, and thank you for sticking to the lightning spirit. I think we're all duly zapped.